Breaking access modifiers. So in this video, we are going to explore some ways in which we are going to break the most basic concept of object-oriented programming. It states that a private variable cannot be accessed from outside the class without using friend function. So just to reiterate, there are three access modifiers: private, protected, and public for the most part in C++. And a private variable can be accessed within the same class, but not in derived class, as well as not outside the class. A protected variable can be accessed within the same class, yes. In derived class, yes. And outside the class, no. And finally, we have the public variable or method that is accessible within the class, in the derived class, and outside the class. So these are basic concepts which is known by everyone. But if you see the grid down below, you'll notice that a private variable can be accessed, yes, within the class, in derived class, yes, outside the class, yes. So this basically breaks the most basic concept of object-oriented programming. There were a few legit cases wherein there was a need to actually test some legacy code to have unit test coverage, and for that there were private variables and private methods that needed to be accessed outside the class. So here we'll open Visual Studio, go to New Project, and we are going to create a C++ project. So go to Other Languages. Now C++ is in other languages. Visual C++, Console Application. We'll give it a project name, whichever you want to give, and hit OK. So here we are going to demonstrate three ways in which we are going to access a private variable from outside the class in C++ using pointers and macros. And now console-based application project with default template comes. We can see the main. Out here, we are going to give a printf statement accessing private variable from outside the class without using friend function. And we'll compile this code to see everything works fine before actually starting to code. So using pointers and reference and macros, we are going to demonstrate three different ways in which we are going to achieve same results. So without using friend function. Now we are going to compile this and a console application is going to come up. We are going to also type get char function so that we can press a button and it takes the input. So it works fine. So we are going to code three different ways of accessing private variable from outside the class. The first method is using reinterpret cast. So reinterpret cast is an operator. Basically, it allows any pointer to be converted into any other pointer. It also allows any integral type to be converted into pointer and vice versa. The second method that we are going to use is without using any function. So what it means is that in the first one, when we are using reinterpret cast, we are going to replace it with our own function, our own API that we're going to construct. So without API, without any API. And the third, so reinterpret cast is actually an inherent function that is already out there that we can use it as I was talking about it. The third method is using C++ macros. So here we are going to define macro hash define to defeat the basic concept of object-oriented programming, which states that a private variable cannot be accessed from outside the class. So first we'll create a class and name it breaking private access m1. m1 is method 1. So now here inside the class we are going to declare a variable, a private variable, private int n pvtvar, private variable, so I've shortened it, n pvtvar equal to, we'll assign it some value out here. So we are assigning this value 10. And now we are going to create a public method, display value, simply void display value bracket start void. This method is simply to display the private variable value. Printf /r/n for next line, value of private variable, %d, and simply the variable name. I could have also used cnc out, but that's okay. Let it be printf. So the concept is to display here the capability of reinterpret cast to break the private a little bit of indentation out here, and then in the main I'm going to start. Let me pull it down a little bit. So in the main I'm going to first, let's say, create an object of the class, which is PAM1 object, private access M1 method 1 obj, and then out here I'm going to call display value. So this is going to display the value 10 because that's the one that's out initialized out there. So now let's say int pointer ptr var is equal to reinterpret cast int of type int pointer and pass the reference to the object that we defined up, PAM1 object. And now in the next line, I'm not going to do anything first. I'm going to copy this display value function and put it out here. So this is going to display 10 and 10 because I haven't done anything. See, on compiling I get 10 and 10. I haven't done anything out here. I've just initialized the pointer. Now what I'm going to do is next is important. Star the pointer that we have, ptr var equal to, let's say I increment it by 1, 11, make it 11. Now when I run it, if you see from outside the class, I am accessing the value of the private variable using pointers, and you can see the basic concept is defeated. We have 10 and we have 11. So that was our first method that we used to defeat the basic concept of object-oriented programming, which states that a private variable cannot be accessed from outside the class without using friend function. And the value of the private variable got updated using reinterpret cast. In the second method that we are going to code now, let me pull it a little bit down. So we are going to create another class, break private access M2. Here we are going to again create a private variable just like we did before. But what is important is that when we are going to create a method, we are going to, along with display method, we are also going to create another catch address method. So private int n pvt var equal to, let's say, 20, and then public. So we are going to create another function called catch address. Now this is just a replacement of the previous reinterpret cast, int star catch address void. This is going to catch the address and it's going to do exactly what reinterpret cast was doing. Return ampersand n pvt var, which is the private variable name. This function out here just serves the basic purpose of defeating the private access. It is not a duplicate of reinterpret cast. Reinterpret cast does way more than this, so which I'm going to talk later. So here void display value void, and then simply printf statement I'm going to give inside it, printf /r/n for the next line, value of private variable %d and the private variable name. So I was talking about reinterpret cast. It does way more than what we have written in catch address, but out here, just to break the private access without using any API, we have coded catch address. Now we are going to code the main function. Out in the main function, so first let me give a heading out here, printf method 1, that looks neat. So we had displayed 10 and incremented it by 1, 11 in method 1. Out here we are going to, in the method 2, we have already assigned the value 20 to the private variable. We are going to increment it by 1 to 21. So copy this method 2, printf method 2, we'll change this. And after this, we're going to take the class name and create an object, PAM2 object, private access method 2 object. Now object dot display value. That's going to display the value 20. That's our initial value that we had assigned. And then we are going to type get char function. So just as an input that we'll be taking, get char, bracket start, bracket close, and then int pointer ptr var1 is equal to PAM2, that is private access M2 object dot catch address. This is exactly the same as what we did previously for using it with reinterpret cast. And then we are going to copy this out here, display, and we are going to run this. Note, I haven't incremented the value using pointer, so you will see that basically both will display 20. Now we'll comment this above code and we'll run the application. So the console window comes up, and as you can see that both of them display 2020 because we haven't incremented. Now we are going to type pointer ptr var1 equal to 21 incremented by 1 value. So 21. Now when we run it, we'll see that the private variable, the value of the private variable gets updated, and we have 20, and when we hit enter, 21. So we were successfully able to update the value of a private variable from outside the class using our custom catch address function that we created. This private value was updated. Now we are going to code the third method using C++ macros. So this is very straightforward. So we'll use hash define, and we'll type hash define and then private and then public. That simply replaces the private with the public at the pre-processing stage. We can do the same for, or let's say we could do the same for protected. So let's say hash define protected public. Here the compiler actually, sorry, I have a bad throat today. So compiler actually loses battle at pre-processing stage only. So let me put it as a comment also out here. Compiler loses battle at pre-processing stage only. With a smiley. Ding. That brings us to the end of this demonstration. First, let me uncomment this code, the method 1 that we used using reinterpret cast, and I want to take a minute to talk about reinterpret cast. I think it's important. So basically, reinterpret cast expression does not compile to any CPU instruction. It is purely a compiler directive which instructs the compiler to treat the sequence of bits as a new type. Remember, as a new type, that's important. Another thing is that when we convert a pointer to an integer, and let's say back from integer to a pointer, what needs to be made sure is that it is of sufficient size, otherwise the resulting pointer cannot be dereferenced safely. So that's important. Since this is not a beginner's tutorial, so I'm not going to get into details about why I didn't use new operator to initialize the object of the class and things like that. But what I want to talk about is when I'm passing the %m1 object to the reinterpret cast operator, that's what I want to talk about. So note here while I'm indentating this, and I just want to copy and paste it out here and make the code look good and comment these codes. The hash defines, it should be on the top section. I defined method 3 out here, so I kind of defined it out here. So this reinterpret cast out here is being passed the object of the address of the object of the class. What it means is that since the private variable that we had defined on top, this private variable is the first one, so the address points to the first variable. Now if there was more than one variable under it, then what you would need to do is that you would need to increment it depending about its 32-bit system or 64-bit system. You will have to increment the pointer in such a way that it points to the right variable. That's kind of a tricky part, but you can map the whole memory of the system using this. That brings us finally to the end of this demo, where we have successfully demonstrated in more than one ways how to access a private variable from outside the class without using friend function. Thanks for watching this video.